color that we fill with yellow. And if you want to compute the area of this region, you need to choose some suitable coordinates. For example, in the picture is OXY, and then you can take integral along some line, for example, along the x-axis or y-axis. If you want to compute the if you want to consider along the x-axis, you need to figure out what is the interval of the interval. At first, you construct a line. For example, in this picture is f equal a. That is a vertical line that touches the region at some point, and the region is lie on the right hand side with this spectrum ridge lines, and then you construct another one that is f equal b that touch the region at some point, and the region is on the left of this line. So if you have so now for each f from A to B, you draw a vertical line through the point with the coordinate x, and then you can see that this line intersects with the region as some segment. For example, in this picture, the segment is the red one, and we say that the red segment is the cross section with the region. Now, in order to compute the area of this region, you need to measure the length of the cross section that we denote by f of x. Here we have a function of f because the length of the cross section is dependent on x. So now you put together to obtain the formula for compute the area of the general region. And now for the similar to case for computing volume in 3 interspace, and now assume that you have some solid in the space. If you want to compute the volume of this solid, you need to consider a suitable coordinates. In this picture is the coordinate OX, Y, Z, and then you can take the integral along some axis. For in this picture, we take the integral along the x-axis. So by the same situation, by the same with the previous case, you need to find the interval interval. For example, here you construct 2 planes. The first plane is alpha, as you see in the picture, that touch the solid at some point, and the solid lie from the right, hand side with respect to our plane, and another one is plane beta that is that we touch the solid, the solid, and the solid is from is from the lab with respect to the plane beta. So you have the domain. So you have the domain of x maybe belong to the interval from A to B, and now for each, now if you for each for each x from A between A and B, you consider the intersection of the plane that that is perpendicular to OX, and in this picture you can see, and then we for each x we need to figure out what is the cross section. The cross section here means the intersection of the plane that is perpendicular to the x-axis and meets the x-axis as a point with the x coordinate exactly x here, and then the cross section is written with the cyan color, as you see in the picture here. And now you compute you let AX to be the area of the cross section. And now we put together in the following formula to obtain the formula for computing the volume of the solid. V equals the integral from A to B of AX dx. So now for this is a very general setting for computing the volume of solids in space, and the step the step you need to do is at first you need to find what is the domain of the variable. In this case, the variable x. You need to figure out, you need to find what is A and what is B, and then for S, for each arc lies between A and B, you need to figure out what is the cross, what cross section is, and then from this picture you can see what is the area of the cross section that we denote by AX. And then from A and B and AX, you put together to get the following formula. This is key step of our study, and the remaining tasks and the remaining work for you is how do we compute this integral. for computing this integral, you can use many methods that you can. For example, you may use the calculator, for example, to get the final result. So we do not focus on how to compute this integral. We focus on the on the so this formula. For example, here is a problem. This is a simple application of this formula. In here, you have to, for example, in problem 1, you have a region in the plane that lie between two parabola. The first parabola is y equal x squared, and the second parabola is y equal 2 minus x squared. In this, you can see in the picture that if you have one parabola here and another here, and then the reason in the plane that enclosed by two parabola is this. And you can see in the picture. And now we can see that it is you can see that the domain is the red color here. And in this picture, you can see the interval is -1 to 1. Exactly as the problem is f equal -1, and the second is f equal 1. And so now, for each x here, you construct the cross section like this, and then you can see that the cross section here. Okay, and now you what is cross section in this problem? That is the circular disc with the diameter exactly is the cross section here. I see. So the problem is and then when x come from -1 to 1, we obtain a solid in the space space that you can see in the right hand side. Is the maybe I draw is not good, but here you can see the picture of here, for example, here's a picture of the solid like this. For example, here, if you you can draw a circle like this. And at another point here, you draw a circle like this. And so on. You have like here. Okay, so like here, and then. And now you can see that this is the picture of our solids. So what is the volume of the solids? So now what is the volume of the solid? The problem here is what is the volume of these solids?
Can I do it?
Yes. Okay. What do you want to write?
So first we find the radius of the cross section area.
Okay. At first, you need to find the domain of x.
Okay, the domain is from -1 to 1.
Domain of x is from -1 to 1. The domain is given in the problem, but we can find it by find the intersection of two curves.
Yes.
Okay, and now for it x lie between -1 to 1, then the
The
cross section is
a circle with the radius.
maybe you can
Yeah.
this we what is radius of this
Is 2 minus x squared minus x squared.
here is it is a diameter.
Yeah, and
So you need to divide by 2.
by 2.
So is 1/2 of what is the length of this cross section here?
Is 2 minus x squared minus x squared.
Okay, this is the y coordinate of this point minus the y coordinate of the rest point, right?
Yes.
And this is maybe 2 minus x squared. This is y coordinate of this point, and now minus x squared. This is the y coordinate of this point. So it is exactly 1 minus x squared. Okay, so now we put together to obtain to get the volume of the solid. V
The integral
is the integral from
-1 to 1
1.
pi.
Here we need to divide by ax, so ax
Yeah.
is here. So I'm sorry, no. Okay, here we only have the
Radius.
figure.
Now we find
And
ax.
so its area is ax equal pi 1 minus x squared, right?
Yes.
Okay, so now we put together to obtain the formula for the volume equals -1 to 1 of pi here. X dx. Okay, and so now what is the value, the final result?
The final is 16 pi over 15.
Okay, see, okay. Okay, this is answer for the problem, because in this problem you